Hi, and welcome back to another video on electronic science. So today we're going to be making something called an astable multivibrator. Now I know that's a pretty silly name, but this name has a meaning, and the circuit is very classic and it's also very fun to make. It's going to look a little something like this. So stay tuned for a video on electronic science. Alrighty then, everybody. So in today's video, you're going to need a couple of materials. So what you're going to need is this 2n2222 transistor. I believe I got that right. If I didn't, I'll put it up on screen. You're going to need 2 of these 2n2222 transistors. That is a real tongue twister right there. You're going to need a capacitor. Now, in this video and for this circuit, the capacitor, depending on what UF you use, what farad capacitor you use, is depending on how fast those LEDs will flash back and forth. Now, in today's video, we're going to be using a 100 UF capacitor, but if you use a higher capacitor in farad, it'll blink slower, and if you use a lower farad capacitor, it'll blink faster. Also, if you use lower or higher value resistors, that'll also vary on how fast or slow your blinker flashes. You're obviously going to need 2 LEDs. In today's video, I'm going to be using blue LEDs, but you can use just about any LED you want. You're going to need 2 1K ohm resistors and 2 5K ohm resistors. Well, I don't actually have a 5K resistor, but the good thing is I have 2K resistors. So what I'm going to do in today's video is put 2 2K resistors in series and a 1K resistor in series to make a 5K resistor. They're coming in the mail soon. I have a whole bunch of electronics coming soon. Just bear with me in today's video, guys. Really sorry. And that is pretty much it. So we're going to get onto the breadboard. I'm going to bring you guys up close onto the workbench, and we are going to create this so-called astable multivibrator. Later on, I'll explain why it's called an astable multivibrator, and we'll wrap it up. So without further ado, let's get started. Alrighty then, everybody. So what you're going to need to do is first take your 2n2222 transistor. I got all the 2's in there correct. And you're going to want to connect it to anywhere on your breadboard. So I'm going to connect it here, leave some pins in the front and back available so that we can connect things to jumpers later. And then you're going to want to take your second one and put it relatively close to the other transistor, just a little bit further down on the breadboard. Just like that. That'll do the trick. And then what you're going to need to do is take your 100 farad capacitor, and you're going to want to connect the negative side to the emitter of the transistor, and then leave the positive exposed on the other side. And you're going to do the same, obviously, for the other side on the other transistor as well. It can go in there. Perfect. And then what you're going to want to do is going to want to connect the collector pin of your transistor and connect that to ground just by a jumper. So I'm going to do that right now. Let's take these 2 red jumpers here. I'm going to connect the emitter to ground. Now, you're going to want to take now your 5K resistor, but in my case, my janky setup, and I'm going to set it up towards down here. So here's my resistors right here. I'll try to get those in frame for you. And I'm just going to connect those all in series on the breadboard to make 5K. And then you're going to want to connect that to the positive side of the capacitor. Just like so. So now what we're going to do is connect the negative side of the capacitor with your 1K resistor. Now here's where things get a little bit interesting. Believe it or not, you're going to connect the negative side of the capacitor to the positive side. Now before you say, oh my god, your capacitor is going to explode, Ethan, what are you doing? Oh my god. Relax, because you would have to connect the capacitor in reverse or overvolt your capacitor in order for it to explode. Now, in order to make a reverse polarity on a capacitor, you would have to connect positive to negative and negative to positive. Here, we're just connecting positive to positive, negative to positive. So, no explosions. So, just do it. Trust me, guys. This is not some, trick here. I'm going to do that right here. Just connect it to the positive rail of the breadboard. Trust me, when I was looking at how you make these, I was like, I think my capacitor is going to explode. But trust me, it's not. Now, what you're going to need to do is slap your LEDs on the board. So what you're going to do is you're going to connect the positive side of your LED, the one with the long pin, to the positive side of the capacitor, leaving the negative exposed on the out. So just like so. That's good. And do the same for the other side, obviously. Perfect. Now what you're going to do is you're going to need 2 more jumpers. And what you're going to do is on the base of the transistors, which is the middle pin, you're going to connect that to the negative of the LED for opposite of the LEDs. So this base is going to go to this negative of the LED, and this base is going to go to this negative of the LED. So this is how it's going to become like an astable multivibrator here. This is where things really get important. So I'm going to do that right here. Just like so. And that is pretty much it. That is all you need to do. So now you're going to need 2 more jumpers, and you're going to connect that to the positive and negative rail on your breadboard. And so this is where things get even more crazy. So in case you didn't know, you're going to need a 12-volt supply for this, whether you use a 12-volt battery, 12-volt supply from your power supply, which I have right here. I'm going to turn that on, set that to 12 volts. Whatever you need. So I'm going to plug that in right now. Alrighty then, we have our 12 volts on our supply. We're going to connect it up. And just you guys wait and see here. I'm going to do that. And so let's see here. Negative to negative and positive to the positive terminal. Problems. See what I did wrong here. Apparently, this part of the resistor that is supposed to be connected to negative, I connected to positive. That is just silly old me. So let's take 2. I'll be right there, actually. Alrighty then, everybody. Sorry about that. That is just me and my stupidity there. But anyways, let me connect it up to 12 volts, and here we go. 3, 2, 1. As you can see, the lights flash in like perfect sync. One stays on for the exact same time as the other. Here, I'll turn off this overhead light. And look at that. You can see there's no delay between the two. And so, as I said earlier in the name, it's called an astable multivibrator. And for those of you who don't know, astable means it is not stable, astable. So, you electronic enthusiasts out there that might understand capacitors a little bit more than me, but don't quite understand the circuit, might say, well, how come the capacitors don't charge up with that positive voltage and the LEDs just stay on? And the reason is, guys, is that not everything is perfect. And that's true. Not everything is perfect. And this is just a perfect example of how the world isn't perfect, really and truly. Now, if you really wanted to make this perfect, you would have to lower your resistor value or really, really significantly lower your capacitor farad level to maybe, 10, 20, 30 farads. And they would probably stay on for longer. But you can see how they flash in sync. Now, you could basically do this if you look up flasher on YouTube, which is just 1, and not the astable multivibrator with 2. And basically, you do a very similar circuit to this, just not connect the base of the transistor anywhere, and you wouldn't connect to the second LED there. And you just connect the negative LED to ground. But that's a different video for a different day. So now I'm going to demonstrate here. I do have higher value resistors, but I'm not going to break them out because I'm getting a bunch of new electronics and drawers and stuff like that. So, but what I do have is a whole bunch of new capacitors here, guys. And while we're here looking at our little astable multivibrator, I'm going to increase the capacitor farad. So let's see. I have a 100 farad capacitor on there. And I'm going to switch them out. Let's see. I'm going to do a 220 farad instead. So it's 120 farads different here. UF. Alright, so here's what I'm going to do. I'm just going to disconnect the negative so that this turns off. And I'm going to just pick up these capacitors here and take them out. The 100 farad ones. And I'm going to put these 220 farad ones as our replacement. Make sure I line everything up correctly. And do the same for the other side. Minding our polarity. Now let's see if we connect it back up. Oops. See? they blink a little bit slower now. Actually, significantly slower than the 100 farad ones. And if I were to even choose an even higher farad one, like maybe, let's see, what else do I have in here? 330, 470. I go all the way up to 1,000 farads in my new capacitor kit. But imagine we'd be sitting here all day if I put 1,000 farad capacitor in there. But you could see when you change the capacitor type, the flashing slows down. But you can see they're still in exact sync with each other. And now if we wanted to speed it up but use this higher farad capacitor, we can maybe take out one of the 1K resistors on both sides going into the positive of the capacitor to make a 4K resistor, and they'd probably blink a little bit faster. I have not tried that, so I'm not sure how that would work. But yeah, let's do a little science experiment while we're here, guys. Let me figure out which one's the 1K resistor. I'll be right back. Figured out which ones are the 1Ks. So I'm just going to take out these 1Ks. And I'm going to stretch these guys out over there. And then I'll take this jumper. Just move that to there. Now, these are two 2K resistors, so I don't know if this is going to work right or not, but let's see. See? It blinks a little bit faster, but we're still using a 220 farad capacitor. All we did was just take out these two 1K resistors, so now we're using 4K ohm resistors now. So now in total we have a 4K resistor going into there because these two resistors here are wired in series, and there are two 2K resistors to make 4K. And you can see it blinks a little bit faster now because we have a lower resistor value. So therefore the capacitors can charge up a little bit quicker and discharge a little bit quicker. So that's very neat. And you can also change the other resistor value here, but I don't recommend it because that kind of whacks everything up. I would just use a 1K here and change the resistor value on the positive side of the capacitor. But this is a very, very neat circuit that you guys can do. And it's very fun. Now, I'm sure if we were to connect these 100 farad capacitors back onto there, it would blink really fast. It might not even work. It might oscillate so fast that we might not be able to see it. Should we do it, guys? Let's do it because I am bored. Let me cut power just so that we don't short anything. Do this, and we'll connect our 100 farad guys back up. Alrighty then, let's see how this works now. Whoa, look how fast that's flashing. That's so neat. That's wild. Yeah, and if we were just to connect the 1K resistor back into there, it would flash like a regular old exit sign type of a thing, you know, how you're on the highway. That's kind of what I designed that other one for. This is very neat, guys. So, yeah. So yes, in today's video, we created an astable multivibrator. So basically how this circuit works is you have transistors, and in this case, a transistor is acting like a switch. It's turning it on and off. And because this is astable and not everything's perfect, like I had said, the capacitor slowly discharges because it has a load on it. In this case, the load is the LED. As the capacitor discharges and the voltage lowers, the transistor switches off. But the other capacitor with the LED that was off has charged, and it charges up to a point where that transistor can switch on, letting that capacitor drain. As that capacitor is draining, the other one charges, and the loop continues, and they keep going. And if you have a higher farad capacitor, it takes longer for the capacitor to charge, or if you use a lower resistor value, it'll blink faster, and if you use a higher farad capacitor, it'll take longer for it to charge, making it slower. Or again, if you use a higher resistor value, it'll still make it harder for that capacitor to charge, therefore slower, and it'll blink slower. So that's basically how the astable multivibrator works. And the reason why it blinks on and off, again, is basically because not everything's perfect, and the capacitor is obviously discharged because there's a load. But anyways, guys, I would like to thank everybody for watching. If you guys enjoyed, please remember to leave a like on this video and subscribe to the channel. Hit that bell icon so you get notified when I upload new videos here on the channel. I would like to thank you guys for watching. Let me know in the comments section below if you'd like to see any cool circuits, have any questions about this circuit, or video ideas. But anyways, guys, I'd like to thank you guys for watching. I'm Electronic Science, and I will see you guys in the next video. Bye, everybody!